go over and take a look at this package unit first. It's a 2014 model. Came out and looked at this job a few months ago. A big tree over here beside this unit had to be cut down. So the owner took care of that. Missed a screw. So one thing for sure, we're going to build a new cover for this ductwork. So basically, this is interesting. The original unit, the return duct and the supply of this unit were on different sides. So when they replaced it, that's not a normal style of package unit anymore. So they did what we call a crossover, but this is not exterior rated flex duct. So we're going to come back in with a black cover or black vapor barrier flex duct to connect to these pipes and build a new cover. Make sure it's sealed up real good to keep animals from getting in here, because that's what this looks like, is an animal got in it. So we're going to go ahead and remove all of this old ductwork and hopefully not get attacked by some random animal. So now I'm going to take some measurements. Pretty sure this is 14. And this is going to be 16. Which means this should be 14. And this is some kind of oblong takeoff, yep. And then we'll take a look at this evap coil. So there's the evap coil. We're going to treat it with a fungicide and antibacterial spray made by a new Calgon called Evap Fresh. It's not a lot of buildup on it. Doesn't need to be you know, brushed or taken out or anything like that. Now we're going to go ahead and check out the electrical compartment. We check the capacitors, look over everything. I don't want to power it up until we actually get the ductwork in it, on it. All right. So one thing I don't like about these models is where they put the capacitor. Right under these breakers here. So capacitor's in there behind all that. If you ever have to replace it, basically have to pull this whole bracket out that the high voltage power is coming in to from the breaker here. Have to disconnect this, take this whole bracket out just to swap the capacitor. Great design by the engineers at a place we will not mention. And well, we really don't need to take that off. We're gonna always make sure that the power is off. So I'm gonna check the ground. This ground is, that screw's grounded, and I'm touching each leg of this breaker, both breakers actually. Everything's dead. I'm gonna look around here and see if I can tell what that capacitor is rated for, and I can't. They have the rating for it pointed up towards the top of the unit, so can't see it, and probably gonna have to take it out to look. But that's for the condenser fan motor and the compressor. So what I'm gonna do, instead of taking it out, is I'm gonna come look at this fan motor. And it takes a 10 microfarad cap. It's right there on the side of the label. And then I'm gonna look on the label of the compressor. And of course, it's facing towards the inside of the unit, so can't see it either. But I have my handy little mirror here, so I'll see if I can't find it. And sorry for the camera angle here. This is a 70 microfarad, so this capacitor should read 70 on the hermetic side to common. And hermetic is that blue wire there, and fan is the brown. And we can leave it set, or we can leave the common wires on, as long as we got the fan and the hermetic disconnected. Check microfarads. Gonna leave one lead on the common. Come over here to hermetic. We're reading 73, which is good because it's 70 for the compressor. And the fan side's reading 10.5. So we're gonna hook this back up like we found it. Blue goes on hermetic, which means the compressor. It's a hermetic compressor. If you don't know what that is, Google it. Capacitor's good. It's a fairly new unit and slightly used. It's a 2014 model. Building's been vacant, I think 3-4 years, so it only got used for 2 years. All that's good. We're going to leave this off so we can check pressures later. So I kind of got a breakdown of what I need on this unit. Need a 14-inch and 16-inch duct. We're going to move on to checking out this little guy. First, we're going to turn the power off. Move this electrical panel. All right. And we're always going to make sure that it's dead. So we're going to check to ground to each leg. Nothing. And somebody wrote 40 on here, but I like to see the label because you never know. Oop. I can find the right nut driver here. There we go. And that's where it was, but you can't read it. It's more than likely a 40 plus 5. I just know that because I've been working on these units a long time. If you're not confident in your ability to know those things, you can always consult the manufacturer. You can probably Google the model number and say dual run capacitor, and it'll tell you which one goes in here. But I'd always go with the manufacturer. You can call Linux, or I'm sure there's some apps that you can download, or you can just punch in the model number and it'll show you a parts list. All right, we're going from common to fan. It's reading 4.96, which is good. Common to hermetic, 39.45. When I don't see a tolerance on the label, I typically go with the 3% because that's the lowest tolerance rating I've seen. So you can take that, you know, if this is supposed to read 40, you can do it the long ways and multiply 40 by 0.03, and that's your tolerance. It can either read that much below 40 or that much above 40. Easier way to do it is to just take that number, whatever the rating for the capacitor is supposed to be, and multiply it by 0.97 if it's 3%, 0.95 if it's 5%, 0.94 if it's 6%, and that'll tell you the lowest it should read, because that's giving you the 97%, 95%, 94% of what it should be reading. I rarely get them right on the edge of the tolerance though. All right, capacitor's good. And we'll go. I see this all too often where people use their air handler closets, alcoves, whatever you want to call them, for storage. Should not be used as a storage closet, because for one, you might be restricting the airflow for this unit, and two, it's going to get dust all over everything in here. This capacitor. And we turn the power off up there at the disconnect. We're going to come back up here. These are your power wires coming in, these blue ones. There's your ground. Gonna check each leg. Got nothing. Guarantee you that's a 5 microfarad capacitor. But again, if you're not sure, take it off, check it, make sure that's what it is, or look at the fan motor label, or contact the manufacturer. It is not a 5. It's a 7.5. I see it written there now. So this capacitor is bad. It was reading like 6 and some change. So, oops. We're gonna go grab a 7.5 out of the truck. And I use a lot, or over the last few years, I started using American-made capacitors. Titan. This is not a product placement, but the only thing I can find here locally is Titan and Trade Pro. And this thing is reading 7.5. So to help our next tech that comes along, I'm gonna leave that 7.5 rating where it can be seen, so you're not having to take it off or Google the model number of this unit or contact the manufacturer or take the blower out so you can see the rating. All about being able to move faster in the future. All right, so capacitor's good. Actually, we're gonna check the heat strips here because we're going into the heating season, and I'm gonna take a look at this coil. It's probably clean considering they're using these 4-inch filters. 16 by 20s. Stick this little guy under there. All right. Coil looks good. So put these pan treats in there. This is a 2-ton. There's a little bit of buildup in there, so I'm gonna overkill a little bit. And their suggestion is 1 to 2 per ton for general maintenance. And this is a coil treatment, or that's what we call it. So I'm not gonna lay under the unit and spray it on that side of the coil. I'm just gonna make sure that I saturate this coil enough to get it all over it. So the idea is for it to go through to the other side. Some people will probably say, oh, you should lay down and spray it. Well, that's fine. You can do that on your jobs. This coil doesn't have any buildup on that side, so this is just a treatment for microbial growth, as we call it. All right, and then that bad boy is dry. It's got some fluid in it now. This is a float switch. We don't install this model, but a lot of companies do. So what happens is, if this is a trap, if this drain between here and outside gets clogged up, it causes this to float, and it should be wired up to keep the unit from running, operating, cooling, whatever. So it's coming in, it's this one, and they broke R going to the thermostat with it, which is good. So it should make the thermostat go blank if the drain ever gets clogged. Basically, it kills the power to the thermostat. So we're going to put all this back together, turn it on, and check actually call for cool. Check the pressures. But first, getting ahead of myself, let's check the heat strips. So we're going to turn this power back on. Nothing blew up, so we're good. Gotta find this thermostat. Oh, it's behind the door. So I'm gonna put it in emergency heat mode. Max the temp out. See what happens here. which it may not be wired up for emergency heat. Yes, it is. And there it goes. So, an easy way to make sure that these heat strips are working without having to get in there with your voltmeter is to just set your voltmeter to amps, okay? Clamp it around one wire coming in. This is a 10 kilowatt heater. So both sets, it's two 5 kW strips. If both sets come on, it should be reading 40 amps. But looks like here they didn't jump out W2, which is more than likely the second stage of heat. Nope, there it went. I thought it went. But I'm not certain that this wire here, no. So what they did is they've got 10 gauge wire coming in. That's only rated for 30 amps. So they've only got 5 kW hooked up to run here, because 10 would pull 40, and that would be an overdraw on that wire. So 5 kW should be plenty for a 2-ton system if it's sized properly. Alright, just going to check the pressures on this unit. This is not a 410A system, so we want to make sure that we bleed any refrigerant from our last system out of these gauges, manifold, whatever you want to call it. Reading anything on that side for a second. Had me a little worried. I really like these ball valve hoses. I use the low loss fittings for years and they just wear out too much, too quick. Over time and start getting stuck and spewing refrigerant everywhere. So I started using the ball valve. So we're going to look at this charging chart. This is a 12 HPB 24. So the subcooling should be 11 degrees Fahrenheit. Okay, so, and it should run for about 10 to 15 minutes before you adjust your refrigerant levels, pressures, whatever you want to call them. So we're sitting at 9.7 right now. This thing's been on about, I don't know, somewhere between 5 and 10 minutes. Gonna let it run for a few more minutes and then check it out. Alright, so we're back out here with my messy back of my truck with our material to finish up this job. All right, so we're gonna start with this elbow here. Good thing this is where I can reach it. And I might have to do some screws from the inside here just to get it to hold. Okay. Well, it's barely in the edge. And I've got an extension somewhere to make this a little easier to do. And these bits are pretty handy. The short one's just like it. It's got a 5/16 on one side and a 1/4 inch on the other. Yeah, this isn't gonna work. So might just have to go from the inside. It's not ideal, but it's better than not having it screwed in at all. And I had my torque turned down for something I was doing earlier. Go. And we may end up masticing this from the inside or sealing it from the inside. Not pretty, but it doesn't really have to be for this. We just want it nice and sturdy. I'm thinking maybe imagine if you've got it here, it's going to move that way, so this is going to be a little excess. I'd rather have a little too much than not enough. Or you'll have to go through this whole process again because your duct's too short. I like to use the serrated side. I've had some guys work with me in the past that like to use the other side. It seems to cut better for me on the serrated side. Alright, and then we need our cutters here. Alright, and we're going to do the same thing on this end. I'm going to fold this insulation back. If you can get the liner to fold back with it, it's a lot easier to just pull it back out. And you know, whole idea here is to make this airtight. So what I'm going to do is put some mastic around this takeoff instead of trying to get all of that tape off. You know, it'll look better with all the tape off, but it's also going to be under the cover here, and we're worried about performance and airflow. If it's exposed where people can see it, obviously you want to make it look as good as you can, but taking all that off is not worth the customer's money to pay someone to sit here and tear all that off. At least I think we are. And I mean, just get messy with it. I always say you don't want to be able to see through it. Just need to put it on thick enough to where you can't see through it, at least. Now we're not going to be able to put a screw through the inside of this one because we don't want to pierce the vapor barrier on this flex duct. Oh yes, fresh mastic. So I think we're gonna have to turn this top piece a little bit. pod in there. And of course, I can't reach it. Okay. So I'm gonna have to do this and then show you what it looks like when I get done. So let's see if we can take a peek up in there. Got all that sealed. Now we're gonna finish up on top. Alright, so now what's left is doing the flex from there to there, which is not going to be fun or easy. Alright, and then what I'm going to do here is when we do the duct wrap, which we're going to let this dry, run out of time today, so we're going to leave this overnight. We're going to butt the duct wrap up to this and then tape this seam the best we can to seal it, and then of course come in with the cowl cover, cover all this with sheet metal, and do our maintenance, clean these units. Alright, so make sure I got enough time here. Yep, just barely. So while I was picking up this material, I had a talk with the owner of this property about these air purifiers, and this building's been vacant for a while. It stinks in there, and these things kill 99% of all viruses and bacteria and that sort of thing that goes through them. So he said he wanted to go ahead and get them and have us put them in. So that's what we're gonna do. So, and I've put quite a few of these in, so I don't need to read the directions, but I would encourage you to, if you're not familiar with how these work. So they'll run on anything from 24 volts up to 240 single phase, and these two maroon, burgundy, whatever you want to call them, wires, we don't need those. They're if you want to wire up an alarm, which this equipment does not have that capability. So we just need the hot, common, and ground. So this thing, the airflow has to come across these in this direction. So let's see here. And the excuse me, manufacturer suggests pre-coil, but we're not using it to treat anything in the coil. We're just simply wanting to kill viruses and that sort of thing that comes through the air. So you can mount it however you see fit. The air's obviously got to come around this fan to get in it, so I like to mount like this, or up here, or you could do it this way. I think that's what I'm going to do. Haven't done that yet. And whatever you do, don't ever get your fingers between these magnets. Some of the strongest magnets on earth, in my opinion. But you got two mounting options. You can put them here or here. Make sure you've got the screw goes in the side with the you know, bigger hole in it. It mounts to the flat side, and you put your nut here. And there we go, we're ready to rock and roll. So, well, that's not gonna work. Let's see here. So I like that too. So what I'm gonna do is make a couple of little holes here to slide those magnets up in, to get a little better contact with the metal up there. There we go. Now we're good. I only want this to run when the fan is on, because it's kind of pointless for it to sit there and be energized when there's nothing moving through it. So I'm going to confirm with my wiring diagram what my G-wire coming into that fan motor is. There's an indoor fan motor. We got 3 different speeds, so not going to be able to go that route. So what I'm going to do is feed these wires into this compartment, hopefully, maybe. Yep. So we're going to push through this. Actually, we might just pull that out. Yep. Drop these bad boys in there like so. And that switch isn't going to make it, so I want to make sure that's on. Shove this gasket back in there. We're all set. wires are hanging out down here. They're actually, that's a bad camera angle, but we pulled them over the top of this whole panel here. So always do the 24 volt application. So white is your common, black is your hot, G is your ground. So what I'm going to do is find my thermostat wire, which is down here, and actually it may be better to run those wires. Black is our hot. We only want it to come on when the fan's on. Well, G is the fan wire, so we're gonna wire it in with G. So whenever the thermostat calls for fan, it's going to energize our GPS Bi-Polar Ionization device, aka air purifier. Now I need to find the common, which on this unit is brown. Okay, there we go. Gently place all those wires back into that little box. And then we need to ground this. So I'm going to go with the equipment ground here. And we're just going to get that bad boy in there, or attempt to. Yeah, there we go. Alright, then you just push it all in there together. Now the screw's coming down on that wire first and pressing it into the big wire. Alright, done with that. The thing is ready to go. Make sure the switch is on again. It is. And we're going to make sure it works. Yep. Running, fans on, and our GPS system is on. So we'll put this cover back on. Oh, look at that, none of it's glued. So, I'm going to take and glue all this together. I think that was it. Doesn't have to be a huge trap. good, actually. Let's turn it. Let me turn it. Alright, so we'll go this way. That way, when they cut the grass or whatever, they won't run over it with a lawnmower and break it off. And then we'll button all this wire and stuff up. Alright, we got a another GPS going in this unit. Trying to get these mounted on these side ones here. It's not quite as easy as the other mounting position, because all these wires are in the way. And we're going to mount this one on the side of the fan here. And again, we don't need these red wires, but we're going to pull them up. Make sure the switch is on. And we're going to zip tie. Oh, I didn't bring any. So we're going to come around this ground as kind of a anchor point. And these are the wires we don't need. And we got our ground here. Hot and common. And I'm going to turn the power off. I want to hook G for the hot. Brought my Phillips head instead of my flat head for some reason. Mr. Clumsy. Alright, that's in there. And then we want white to common. Make sure you twist these ends. You don't want any loose wires or little frayed pieces of wire touching the cabinet or another wire. It can create a nightmare for troubleshooting. Alright, that's done. Now, I'm gonna try and get this ground in here. Oh, yay. I wasn't expecting my can opener in to be able to do that. It's gonna be opened up a little more. There we go. Plenty of room. All right, there we go. And that one's ready to go. Okay. Alright, and now what we're going to do is leave the fans in the on position until we come back or the owner comes by. That way they can help take some of the smell out of here. The vacant building smell is what we'll call it. So it's set to cool. We're going to do fan on. Air set to 80. Want to keep the humidity low. This unit's pumping out some good air. We're going to leave the fan on. I'll set the temp to 78. Just heard the compressor kick off.